Good evening, everyone. I'm Calvin Joseph, and today I'll conduct your week 3 problem solving and doubt clearing session for this NPTEL course, Digital Circuits. And this was taught by Professor Santanu Chattopadhyay. Okay. So, unless you're saying something, don't please be muted. Okay. Right. So, this is the week, what and all is there. So, this week, that is week 3, we will be doing about combinational function minimization. What is K-map? What is Boolean algebra? Boolean identities, we will use them. So again, this is, the last date for exam registration is 14th August. So I'll advise you guys to register quickly and you get a certificate and kindly use the portal a lot. The various features are there, which you would find to be very handy for you, right? Yeah. Okay. So the exam date is 24th October. It's a Saturday and fees is 1,000 rupees, and the exam marks and criteria also you guys would know by now, right? So for today, this is what we are going to focus on today. We will cover slightly what is SOP and POS, which was from the previous week. Then further what is K-maps, which has been taught a lot, 2 variable K-map, 3 variable K-map, 4 variable K-map, what is don't care condition, and etc. Then logic circuits, logic gates, which you guys, many of you will be familiar with it. It will be something very basic, something very simple, but it's like the foundation stone. Like you need to know that well, such that you can become strong in digital circuits, such that you can easily, with ease, you can check answer various questions and all. Okay, so as you go further in the course, this K maps and these logic gates, they are what will be added more and more, done more and more. It's like you're going to build on those top of those things. So you should focus on them. You should learn it very well. Okay. So yeah. So we will start week 3. Week 3. Let us start with K maps. Suppose you have a function A, B, Y. Okay. You have a truth table that is 0, 0, 0, 1, 1, 0, 1, 1. Okay. Let us say the outputs which we get are 1, 0, 1, 0. This is the output Y. So now you need to find out what is the expression for this. Okay, what is the Boolean expression for this? One way in which you can do is you can say Y is equal to what? A bar and B bar, or A and B bar. Right? This is one expression. So now this is the expression. Any doubts in this part? How Y is come like this? So this is like your min terms, right? Your min terms. This is your M0, M1, M2, M3. Where what is M0? M0 is A bar, B bar. And this is what? A bar, B. This is A, B bar. This is A, B. So your function Y is what? Summation of M of 0 and 2. That is why it is A bar and B bar plus A and B bar. So can this expression be made more simpler? Is there any way? Can you make this expression more simpler? Is there any Boolean identity or something which you can use to simplify this expression, make it more smaller so that you can use less number of logic gates?
A plus A bar equals to 1, sir.
Yeah, very good. So you take B bar common and then you have A bar plus A and B bar. So that is equal to 1 into B bar. So that is why it is equal to B bar. Okay, very good. So now this is using identities we can do. But what if we have to use it using K-maps? Okay, so let us try. Some of you may know, some of you have gone through the lectures, you will have a good idea. So let us just revise it. Okay, let us just go through. So for K-map, we draw like this. For a two variable K-map, this is how we draw. This is your variable A, this is your variable B. Okay, first row is A bar, next row is A. First column is B bar, next column is B. Okay, so this is your 0, 0, this is 1, and this is 1. Okay, so when both are 0, 0, your number is 0. When 0, 1, your number is 1. 1, 0, your number is 2. 1, 1, your number is 3. Okay, so this is how the numbering you do of the K-map, the each block you number. Now, it is at M0 and M2. So that means where you place a 1 over here and a 1 over here. Okay, so this is now your K. This is how you have just represented it. In K-map, you have drawn the K-map and you have represented it. Now what you have to do, you have to minimize it. So you have to take, there is a common thing, right? You can take a common. So you make what is known as a, there's a octet, one thing, let us say, you have what is known as a pair. You form a pair. Okay, you form a pair. And then in that pair, when you see that pair, you see what is common. See, A bar and A is changing, but B bar is remains the same. That is why your output Y is equal to B bar. Okay, this is what your K-map will give. So let me repeat it once more. We have found out using Boolean identities that the function Y, which we have defined based on the truth table, that is equal to B bar. Okay. Now we have, so we know Y is equal to B bar. That is confirmed. So now we are trying out a different method. Okay, different method. We are starting with a very small two variable case such that, we get confidence in this approach. Okay, so what we do is we draw the K-map, A and B is there. Then the first row is A bar, second row is A. Third, then the first column is B bar, second column is B. Now, accordingly, you have 0, 1, 0, 1, you have represented it. Now, we have to write like, this is 0, this is 1, this is 2, this is 3. We write it down. Okay. Then what are the minterms? The minterms which you have, what are they? Your minterms are M0 and M2, right? So we represent M0 and M2 by 1, 1 in the K-map. Now, you can group them. So you can either group them in pairs, or you can group them in quartets, or you can group them in octets. Pair means 2. You can combine 2. Okay, so when you combine 2, what happens? You see which of the variable is changing. A bar and A are changing, right? But which variable is not changing? B bar. B bar is not changing. That's why you write Y as equal to B bar. Okay, so this is a very simple example. So let's try some other example. Let's try. Okay, let us say we have a function Y that is summation of M. Okay, let us try summation of M 0, 2, and 3. Okay, this is a function. Summation of M 0, 2, and 3. Let us draw it in the K-map. This is how we draw in the K-map, right? This is A, this is B, this is A bar, this is A, this is B bar, this is B. Okay, and then numbering 0, 1, 2, 3. So which and all are there in this K-map? You have 0 is there, 2 is there, 3 is there. Okay, so we know what is our Boolean expression. We have got it, like we know what are the min terms. We have represented it in the two variable K-map. And now we have to, do the optimization, or we have to do the grouping. So now we have to group them. So So you can group them in pairs of this and pairs of this. Okay. Now you have, let's go one by one. So the first grouping. In the first grouping is same like the previous grouping, right? First grouping is same like the previous grouping, so it will be B bar. Okay. The next grouping is this. Oh, sorry. Like this. This is the next grouping. In this grouping of red grouping, which variable remains the same and which variable changes? Can you tell? Can someone tell? We have so many participants. So can anyone say which, like, is B changing or A changing? Which variable is changing? In the second pair, is B changing or A changing? Okay, Akash is saying,
changing.
okay, people are saying B, very good. Thank you. Thank you for your responses. So B is changing. What is not changing? A. Okay. Is A changing or like, so the variable is A. So that's why Y equal to B bar plus A. Okay. Yes. Good. So now what was, so this is Y equal to B bar plus A. We found it from the K map. But if you see Y equal to summation of M 0, 2, 3, that actually what it means, that is equal to A bar and B bar plus A and B bar plus A and B. This is the actual expression. The actual expression is what? A bar and B bar plus A and B bar plus A and B. Huh. So now we found that this is the answer from K-BAP. Is it correct or not? Let us verify. Okay, let us check. Huh. We have lots of, insomnia, or we are very insecure whether we have done it right or wrong. Okay. So let us check. So we'll write the expression here, y equal to A bar and B bar plus A and B bar plus A and B. So how you can write it down as A bar and B bar plus A common B bar or B. So it is what? A bar and B bar plus A and 1. So it is A bar and B bar plus A and 1. Okay. Now how do we simplify it? We write it as A bar and B bar. Let's write here. It is A bar and B bar plus A and 1 plus B bar. 1 you can write it as 1 plus B bar as well. Okay, this is a Boolean identity. So then this will become what? A bar and B bar plus A and B bar. So you can take B bar common, so you get A bar plus A and B bar plus A. So this becomes equal to B bar plus A. Okay. This is what we had got previously. So both this expression and this expression are matching, right? So that means we can say the what we have done is correct. Okay, someone is saying something. Okay. So any doubts, any queries still here? Any doubts, any queries? Or I can go to the 3 variable K-map. Okay, very good. All right, so let us go to the next topic. Let us go for a 3 variable K-map. 3 variable K-map. You have A, B, C, Y. Okay. So what is this 0, 0, 0, 0, 0, 1, 0, 1, correct? 0, 1, then you have 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. Now, this is your M0, M1, M2, and so on. You go to M7. Okay. So now let us represent it. So how do you represent the K-map? You write it like this. This is the K-map for 3-variable case. This is your variable A. These are your pair of BC. Okay, pair of BC. This is your 0. This is your 1. Then here is the trick. This is the part where you have to be careful about. BC, how you start with 0, 0. Then what do you make it? You make it 0, 1. Then what do? You don't make it 1, 0. You make it 1, 1. Okay, because you want to make sure that only one bit is changing, one variable is changing at a time. And then you make it 1, 0. Okay. So you draw like this. This is like your K variable, 3-variable K map. And if you can notice, in these two columns, your C does not change. Okay, in these two columns, your C does not change. This remains as C. In these two columns, this is your B. Your B does not change over here. Okay. So what about, and for row 1, this is your A bar, and for row 2, this is your A. All right. So you are able to understand, right? So this is what? This is B bar and C bar. This is B bar and C. This is B and C. This is B and C bar. Right? Since, why is this B? Because this is B. This is B and this is B. That's why these two rows combine to form B. Similarly, why this is C? Because these two columns have C as common. Okay. So if you can group them, you can get it in terms of C. Okay. Now, this will be your variable. This will be your variable 0, 1, 2, 3, 4, 5, 6, 7. This is how you must number it. Okay, this is how you must number it. So let's try one more time. So you make your K map A, B, C. This is your 0, 1, 2, 3, 4, 5, 6, 7. Okay, this is what 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So let us say you have to find the simplified expression for summation of M. 0, it is 0 you have 5 you have, 7 you have, 6 you have. Okay, so you have 0, 5, 7, and 6. So how will you find the K map for this? You have to group it into pairs. Okay. So when you start grouping, what can you group? You can group these two. You could also group these two. But can you group this with anything? You cannot group it with anything. Okay. So then your final expression will be Y. Your Y, let us start with the single one, the single guy. What is Y? This one, what is this? What is this one? This is equal to A bar and B bar and C bar.
C bar.
Okay? Yes. Now let us add to this expression. We will start with, let us say, this one. In this one, what is remains the same in the row wise? It is A.
A, C.
A,
A, C.
And next one is C. Good.
C.
And
Plus
the
A,
next
B.
one, this
A,
one,
B.
yes, it is A and B.
B.
Yes. Okay, so this is the simplified expression for this case. It's a simple case. So let us try a little bit difficult case, because you guys have to face challenging things, challenging questions. So Again 0, 1, 2, 3, 4, 5, 6, 7. Okay. Let us assume this is 1, 1, 1, 1. Very happy we are. And this is 1, 1. Okay. This is the K map which we have to do, where this is your A, this is your BC. Now, how can you simplify it? You can group it into 4.
Four.
Yes. So you can group these two together, right? And then you can also
Yes.
these.
No, and also four characters.
Yes. Yes. Okay. So now you tell me what is regarding this one in blue. This is regarding what? It is what variable. So let us say this is your A bar, this is your A, this is your B bar, C bar, this is your B bar, C, this is your B and C, this is your B and C bar. Okay. So in the first blue expression, when you do the grouping of 4, when you do grouping of 4, two variables are eliminated. The variables which keep changing, those variables are eliminated. So is A changing? Okay, Tanushri is saying B bar, but let's check with others as well. So in this blue quartet, is A changing? Yes, it is changing. A and A bar are changing. Further, is B changing? No, it is B bar and B bar. What about C? Is C is changing? Yes, it is changing C bar and C. That is why that expression Y will have B. Okay. Now let us see the one regarding the one in green. In this expression, you will notice A
A,
remains fixed. Yeah. B and C
B
keep
plus
on
A,
changing. Okay. So this Y
B
equal
plus A,
yes. So here Y equal to B plus A. Oh, sorry, B bar. Sorry, B bar plus
plus
A.
A bar.
Yes. B bar plus A. B bar plus A. Right?
Yes, sir. Yes, sir.
Very good. You guys are catching my mistakes. It's good because yeah, I make a lot of mistakes. Hmm. So yeah. Hmm. Now, why don't we see? This is one case. Let's try one more example. An interesting example where this is again your A, B, C, 0, 1, 2, 3, 4, 5, 6, 7. Okay. Let us say we have a 1 over here. Huh? We have 1 over here, 1 over here, 1 over here, and we have a 1 over here. So now, uh, let's say, how do we group it? We'll start with the big numbers, things which we can group 2 by 2, 2 by 2, right? So this we can group it as 2, right? Then uh, this also we can group it as 2, right?
Yes,
What
sir.
about this guy? Is this a single guy or you can do something about him as well?
It can be paid with
Yes, very good. Yeah, so it is not immediately clear. Okay, not immediately clear, but you can notice that this guy can be paired with this guy.
Yes, sir.
Yeah, let's not say guy, that this one can be paired with this one. Okay, so
A
it is.
bar C,
Hmm. Okay, let's slowly write. So this is your A bar, this is your A. Okay, this is what your B bar and C bar. This is B bar and C. This is B and C. This is B and C bar. So what you have to realize is for the green pairing, C bar is
A
same
bar
here,
C bar,
bar is also
A
same
bar
here.
C bar.
Yes. Yeah. So it is kind of like a folded thing. That is, it is like a circular map. Okay, it's like circular. That is, the right side is also joined to the left side. Okay, the right side is also joined to the left side. So that you must keep in mind because that is a tricky way. If you're not very careful, you might miss that. Okay. So then, so your y will be equal to what? A bar. A bar
C
remains.
bar
C bar also remains same. So A bar and C bar.
plus A bar B
Yes, yes. Let's
plus
go
A bar
slowly.
B.
Let's go slowly. Slowly. I'm not too
Okay.
fast. Huh.
Okay, sir.
In the blue expression, there's blue expression. A remains same. And then what is remaining same?
C.
C is remaining the same. Okay. Now for the orange expression, what is remaining the same? The row is the same, right? Row is
A
the
bar
same. So A bar comes
B.
there and then
B.
next B. Okay. Okay. Right.
Okay.
So can this expression be made even more simpler? Can you make this expression even more, can you do some Boolean identity or something and make it more smaller or not?
Yes, sir.
Can you check whether can you make it simpler? Okay, how can you make it more simpler? That
A
this is
bar
your
C bar plus AC equals to 1, sir.
no. How? It's not possible. How A bar and C bar plus A and C, how is that equal to 1?
C plus C bar equal to 1.
No, but this is A bar, no? This is A, right?
Yes, sir.
You cannot group them.
A bar and A bar get common.
Yeah, see, you can do. Okay. Let's go with you guys' suggestion. So you take A bar common. Very good. Then you can get B or C bar, right? This is one expression. Yeah, you get it to this expression, but I'm saying you cannot eliminate anything else, right? I mean to say you cannot eliminate anything. Like, I think I did not communicate the question properly. So in the previous case, let us say over here, we have, suppose you have this expression, right? You have this expression A bar and B bar plus A and B bar. What you do, you can do some Boolean identity and you can get it in terms of B bar. That is, you can eliminate some variable, right? You can eliminate some variable. Similarly, in this case, this is A bar and B bar plus A and B bar plus A and B. You could do some Boolean expressions and you can eliminate so many, like you can eliminate some variables and you can get a smaller expression. Okay. That's what I was asking. So in this 3-variable K-map, can you do any such kind of Boolean identity or Boolean expression, something to eliminate any variable or not? What do you say? Is it possible or not possible? Okay. Tell. Yeah, you cannot do any more. Yeah, Tanushree, you cannot do any more thing. It is like
Yes.
the optimized expression. Okay.
Yes.
All
Okay.
right. So this is done for this. Now,
That is
tell.
like consent theorem.
Repeat. Can you repeat again? I couldn't hear.
That equation like consent theorem.
Okay. I'm really don't remember consensus theorem now. I don't remember it. Yeah.
Okay.
Okay. So now, is there any other way we can make this simpler? There could be also no. This is the one. This is the expression. Okay. So now, what about 4-variable K-map? Let us try 4-variable K-map. Yeah. 4-variable K-map means you have A, you have B, you have C, you have D. And you will have 16 boxes. Okay, 16 boxes. Now, how do you represent all these 16 boxes? Let us see. So, you have here AB and here you have CD. Okay. 1, 2, 3, 4. Okay, 1. So let me draw one more. This is another row. So how do you number it? In this case, it is 0, 0, 0, 1. Then it becomes 1, 1. And then it becomes 1, 0. This is also 0, 0, 0, 1. Then it becomes 1, 1. Then 1, 0. Okay. This is important for you to remember. This is the standard. You have 0, 0. Then you make it 0, 1. Then you make it 1, 1. Then you make it 1, 0. This is the method which is usually used, right? There could be other methods like, AB could be this side, CD could be this side, something like that could be there. So this is not like a very unique, only way you can do. There could be a different way. But to what approach usually I have seen, AB and CD is there. Okay, AB you group it together, CD you group it together. AB you have 0, 0, 0, 1, 1, 1, 1, 0. CD you have again 0, 0, 0, 1, 1, 1, 1, 0. Now the overall expression, that is A, B, C, D together, you will get, what you get is, change color. You get this as 0. Then you have 0, 0, 0, 1. This is 1. 0, 0, 1, 1 is actually 3. 0, 0, 1, 0 is 2. Okay. Then you have 0, 1, 0, 0 is what? It is 4.
4.
0, 1, 0, 1 is 5. 0, 1, 1, 1 is 7. And 0, 1, 1, 0 is 6. Okay. Now you have 1, 1, 0, 0. 1, 1, 0, 0 is what? It is 12. 1, 1, 0, 1 is 13.
13.
1, 1, 1, 1 is 15.
15.
And 1, 1, 1, 0 is your 14.
14.
Okay. Now you have 1, 0, 0, 0. That is your 8.
8.
1, 0, 0, 1 is your 9. 1, 0, 1, 1 is your 11.
11.
1, 0, 1, 0 is your 10. Okay. This is how you number it. This is how you number it. I recommend you learn how to number it and practice numbering. You can practice it while you're doing your sums, etc. Because once, if you get a number wrong, your answer is wrong, right? And if you know this numbering method, you can do it faster. You can do it quickly. Okay. So initially, when you study, the objective is not that you should do it fast. Okay. You should not have the JEE advanced mentality that 1 minute, one sum solve. That mentality doesn't usually is necessary. It's not necessary over here. When you're starting to study a subject, it will take more time. It will take lots of time. Then when you're revising, it will become faster. Then when you do your next revision, it'll be a little more faster, usually. Okay. So that's how you should do. You should understand that these things will take some time. And it's not that if it is not happening in your first attempt, that is you give up hope, saying that this subject is too hard, I cannot do it, this is beyond my capacity. No, you should not think like that. You do it once, you may understand some part. Okay. You do it second time, you will understand a little bit more. You do it the third time, you will understand a little bit more. That way. And also you should understand that, see, I'm not perfect person. I will not be telling you everything. I'll not understand you're at which situation, how much you understand, how much you don't understand. So what I say may not be the complete thing, right? So I feel that the best way to study is doing self-study. That is, you try doing it on your own. You try practicing it on your own. But that doesn't mean you don't attend lectures, all that. But you should attend lectures. They are like your supplementary thing, and your self-study will make it, more better. Okay. So let us try one more time. Let us do another 4-variable K-map. Another example of let us practice. Let us practice. Okay. So how you start? You have 0 here, 1 here, 2 here, 3 here, 4 here, 5 here, 6 here, 7 here. Then I go down. I go 8, 9, 10, 11, 12, 13, 14, and 15. Okay. See, this I done it because I have been doing it for many times. So that's why I could write it quickly. You also, once you practice it, once you get the flow, you'll also soon be able to do it in a bit more easier fashion. Some of you would know it very well. So for you, it is very simple. But for those who are new, I was just stressing it out. Okay, so now this is your A, B, this is your C, D. You should remember this is your 0, 0, 0, 1, 1, 1, 1, 0. Yes. This is your 0, 0, 0, 1, 1, 1, 1, 0.
0.
Okay. So now we have gotten the practice of how to write the 4-variable K-map. Okay. How to write the 4-variable K-map, we have understood. Now let us try an example. Okay. Let us put some numbers, 1, 0, everything. See how better we can group it, everything. Let's try. So now let me put a 1 over here. Okay. 1 over here, 1 over here, and a 1 over here, then a 1 over here. Let us also put 1 here, 1 here, and 1 here. Let's try. Okay, let us try. So now, what can we do? So when you see it, you should understand first, this is it has 16 elements. Okay. Either you can make a group of 16, which is usually not the case. So then you divide by 2. Can you make a group of 8? Is there a combined group of 8 which you can do? It doesn't look like it. So then you go to 8 divided by 2, you go to 4. Can you make a quartet, a combination of 4s? Right?
Yes.
Yes. So as you are saying, you can make. Which one? This is a combination of 4.
Yes.
You have made a combination of 4. Good. Now, can you make a combination of 2? Where can you group 2? Like, see, these 4 ones are grouped together. Now you don't need to focus on them. You can use them for grouping in the next case, but it's not necessary that you must focus on them. It's like, I mean to say, you don't need to do this group of 2 here, group of 2 here. That is meaningless. Okay, you don't need to do that. So now you have to make group of 2s now. So one simple thing which just is easily visible is you can group this. Okay, you can group it.
Yes.
You have
12,
grouped it.
13.
12, 13 also you can group, right? You have grouped it.
Yes, sir.
You have paired it.
2, 10.
And 2, 10.
10. Yeah, good. That is the thing. That is the slide.
10.
Yeah. 2 and 10 also you can group it. Okay. So
Okay.
now how do we 2, 10? That's a good thing you got it. So let us say. So this is actually your A bar and B bar. This is your A and B bar. This is your A and B. This is your A. Sorry. This is your A bar and B, and the last row is A and B bar. Okay. For here, it is first column is what? C bar and D bar, then C bar and D, then C and D, and C and D bar. Okay. Let us now start. We have to find the simplified expression, that is y. What is the one in blue? The one in blue, in that quartet of 4 ones together, which variable is A changing, is B changing, is C changing, D changing? Which variables are changing? Which variable? Okay, let's tell me which variables are changing in the quartet of 4 ones. Which variables are changing?
A and C are changing, sir.
Okay, A and C are changing. Very good. So if A and C are changing, so A and C will get eliminated. So what is left is B and D. Okay.
B and D.
Yes. So it is B and D. Okay. Now I want you to focus on the red one. Red one. In that, which 2 variables are changing? Or no, let's not go in that way. Let us say which variable is not changing. Which variable is not changing?
B bar.
A bar, C
A
bar,
bar,
D.
B bar,
A bar.
A bar.
Okay. Okay, yeah, which variables are not changing? So C bar and D are not changing, right? C bar and D are not changing because they are common for both of them
A
because
bar,
they're in the
A
same
bar,
column.
A bar also.
A bar, C bar, D.
Correct, correct. And then in the other place, when you look in the row way method, A bar is not changing. So that's why it is A bar and C bar and D. So because it's a pair, what is eliminated? B is eliminated. The variable B is eliminated. Okay. Yeah. Okay. Right. Let's go to the purple one. In the purple one, which variable is changing?
A, B, C bar.
Okay, so D is changing. So that's why you get the expression A, B, and C
B,
bar.
C bar.
Yes.
A, B, C bar.
Yeah, very good, very good. Now let's go to the last green one or the black one. What is that? It's like the folder one. So in that, which
B,
variable is changing?
A changing.
D
A is
bar,
changing.
C, D bar.
Yeah, very good.
B
So
B
bar
bar,
changing.
C, D bar.
yeah, D bar, C, D bar.
B bar changing.
Yes, yes, yes. Okay. Yeah. All right. So any confusions in this? Any doubts, any queries in this?
No.
Okay. Assume now
No.
we'll add what is known as a don't care. Okay, we can add something known as a don't care. Let us write it down. Let us put the don't cares over here. Which color is not used? Let's add in green. I add a don't care here and I add a don't care over here. Assume. Also, yeah, let's keep it at this much only. I add these two don't cares. What is a don't care? Can anyone tell? Can any of you, write a message or unmute and tell?
For SOP, don't care value is 1.
Tell again, tell again. Okay, Ashwini.
Hello.
Yes, tell.
It's an output which is not affected by the value of the input.
Yeah, kind of like if those inputs are there, it doesn't make a much of a difference. Yes. Ashwini is saying, yeah, we can place 0 or 1. Okay. So that means those inputs are not really important for your output. Or if your output becomes 0 or 1 for those inputs, it doesn't make much of a difference. Now, if it doesn't make any difference, then why should we include it in the K-map? What is the advantage if you include it in the K-map? So that you guys would know, but I'm just telling you guys that if you can consider it to be 1 or you can consider it to be 0. If you consider it to be 0, in this case, it will not have any impact. Suppose I consider these x's are represented as 1. Then what you can do, you can make this folded K-map. You can make this like this over here. This also is common. This also is common. This also is common. Okay, you can get a folded K-map. Okay. Now I want to actually drill that concept. So that's why I want to take that thing. So now this is a new thing. Let us say for all those 4 things which I have drawn. Okay, let us say like this one, this one, this one, and this one. Let us write down each thing. Let us say this is our new focus. Now we'll focus on those folded elements. Okay, we'll focus on those folded elements. Okay, if you look at the first element, what it is A bar and B bar, C bar and D bar, right? So it is your A bar and B bar, C bar and D bar. Okay, let us focus on the bottom left. What is that element? It is A and B bar and C bar and D bar. Okay, D bar. Let us focus on the top right. What is that element? It is A bar and B bar and C and D bar. It is what? A bar and B bar and C and D bar. And if you do on the focus on the bottom right, what it is? It is A and B bar and C and D bar. It is A and B bar and C and D bar. Okay. Now what you do is you look into all these four individual elements, which are at the the four corners of your K map, to which I am saying that they are folded, they are connected in some manner. So let us just investigate it properly. So if you look at these four elements, you will see that two of the variables are same throughout all the four elements. Which are those variables?
B bar and D bar.
Correct, right? If you look,
B bar, D bar.
B bar is remaining the same here, huh? And D bar is remaining the same here. That's why it is these all, when you combine it, simplify it, it boils down to B bar and D bar. Okay, boils down to B bar and D bar. Any questions in this, or you want me to repeat it once more?
Nothing, sir.
Okay, very good. All right, so let's assume there's no questions in this and we'll proceed. Okay. So let's now go towards the SOP and POS. Okay, what is the full form of SOP?
Sum of product.
Very good. So this is sum of product.
Product of sum.
Product
Okay.
option.
POS is product
Option.
sum. Okay, very nice. So now you have SOP. Okay, you have SOP. And so I've actually muted everyone. You can unmute also. When you're answering, you unmute. When you're not actively answering or asking questions, kindly be muted. Okay. So SOP is a sum of product. What it means is you have something like you have B and C, and then you have plus A and B. Then you have something plus A and B bar and C bar. Something like this. This is known as, these are your, this is your product, this is your product, this is your product, and this is your adding, right? You're adding. That is why that is known as your sum, and these are your products. Okay, these are your products. Now, you can also have something known as POS, product of sums. How does that look like? How does that look like? That looks like A or B. Then this is one sum. Okay, this is another sum. Then you can have a sum, what is B or C bar. You can have another sum, that is what? A plus C, right? And what you can do to this, you are multiplying it sort of. It is not exactly multiplication, it is AND operation. So it is written as product of sum. Okay, it is known as product of sum. Now, we are more, at least personally for me, I find sum of product SOP method easy. It is more intuitive, more understandable, and all, because we are more used to, doing all the ANDing and then you do the ORing. Then you find SOP is better. But if you go for POS, what you're doing all the OR operations and then you're doing the AND operations. Okay, and to what I recollect, I think week 4 and week 5, week 4 and week 5 also may have something more about this. Okay, there are more things which you will learn. So now, why should we go on POS method? Why should I focus on that? Let me give a different outlook. Let us say you have a 2 variables. Let us focus on 2 variables. Okay. So usually what I prefer to do when trying out some new concept is I prefer to do it in a simpler method usually. Okay. So you also try to do that method. That is, if you understand a concept in 2 variable thing, then you can increase it and make it 3 variable, 4 variables, so on. You can increase the complexity. Don't directly jump to a higher number of variables and try to understand. It may be a little bit difficult. It's not like you will fail, but it becomes slightly difficult. So let us take 2 variables. You have A, B, Y. Okay. So let us say this 0, 0, 0, 1, 1, 0, 1, 1. If you are going in terms of min terms are for SOP. Okay. And you have max terms are for POS. Max terms are for POS. So this is your M0, M1, M2, M3. And what is your M0? That is what? A bar and B bar. M1 is A bar and B. M2 is what? A and B bar. And M3 is A and B. Right? Okay. Now what is your M0? What is your max term? M0 is A or B. It is not A bar or B bar. It is A or B. What is your M1? It is your A or B bar. Because B is 1, it is represented as bar over here. And because A is 0, it is represented as A over here. In the max term, it is an opposite concept. What is your bar becomes, what is your A becomes A bar? What is your B becomes B bar? And your AND gets converted to OR. Okay. What is your M2? It is A bar or
bar plus B.
What is your M3? This A bar or
plus C bar.
so very good. So now we have done this. Let us try what. Let us say our output y, one output y. That is equal to. Let us say it is 1, 0, 0, 1. Okay, 1, 0, 0, 1. This is the output which we have. So in min terms, what you get, it is summation of m. Okay, let's make it a simpler thing to not complicate it. Let's make it 1, 0, 1, 0. Okay. So in terms of summation of min terms, it is what? 0, 2. And in terms of max terms, it is the product of 1 and 3. Okay. So let me just do. So let us say in the min terms, it is 0 and 2 because 1 and 1. And in the max terms, what it is? It is the product of 1 and 3 because those are the zeros. Okay, product of 1 and 3 because those are the zeros. Now, if you write summation of M0 2, what does it signify? It is A bar and B bar or A and B bar. Okay. If you write product of M of 1, 3, that is what? It is your A or B bar,
Plus.
this one. And M3 is what? A bar or B bar. Okay. Yeah. Any confusion still here? You let me know. This is a slightly difficult part. It's not difficult. It is a little bit not exactly as we are familiar with, it's slightly unfamiliar. Okay. If you have any questions, you let me know or I'll proceed further. Okay, no questions?
No
All right.
questions.
Okay, thank you, thank you.
Proceed.
Okay, so now, how do we know that this is correct or this is correct? So the truth is that both are correct. Okay, both are correct. And both can be simplified. So how will we simplify it? Okay, let us start with a difficult one. Okay, with the product of this. How will you simplify this? How will you simplify this? Let us multiply it. Okay, what this becomes A and A bar, right? A and B bar, or B bar and A bar, or B bar and B bar. Okay, so what is A and A bar equal to?
1.
A and A bar is 1. It will be 0, right?
0.
Yes, 0. Yeah, it's a little bit. Usually we were doing A or A bar, so that's why that is equal to 1. But A and A bar, that is equal to 0. Okay, then this is what A and B bar. Fine. This is again what A bar and B bar. And what is B bar and B bar equal to? B bar and B bar is what?
B bar.
B
B bar.
bar and B bar is B bar. Okay, very good. Now what we can write is, we can take A or A bar common, like B bar or B bar. So this becomes, what does this become equal to? This becomes equal to B bar or B bar. So that's why this is equal to B bar, right? This is equal to B bar. So this product of M1, 3 is actually equal to B bar, right? And let us go back to our summation. Let us write our summation of M 0, 2, what it was? A and B bar. Oh, sorry, A bar and B bar, or A and B bar. So that is equal to what? A bar or
B
A
bar.
and B bar. So that is equal to B bar. Okay. Yeah. So I've just taken a very simple example so that you all will be convinced that what is your min term, what is your max term, how do you represent it? Min terms you focus on the ones, max terms you focus on the zeros. Okay. Yeah. So this is done. So let us try one example which I thought would be a little bit useful. Yeah. So this example, we are slightly increasing the difficulty and we are trying out using K-maps. Okay, let us use K-map, right? Three variables K-map. Let us try. You have A over here, BC over here, 0, 1, 2, 3, 4, 5, 6, 7. Okay. We will have ones to be over here. So 1, 2, 3, 4, and 1. And these are all 0, 0, 0. Okay. This is all 0, 0, 0. So now, how do we group it? So this actually is what? This actually is your 0. This actually is your 1. This is for your 0, 0 case, 0, 1 case, 1, 1 case, and 1, 0 case. Okay. So now, this actually is equal to your A bar, right? This is equal to your A. And this what your B bar and C bar, B bar and C, B and C, and B and C bar. Okay. This is in terms of your min terms. But if you will write it in terms of your max terms, this will be B or C. This will be B or C bar. This will be equal to your B bar or C bar. And this will be equal to your B bar or C. Okay, this is in terms of your max terms. It's just the opposite. Okay. Now, let us go with the standard way. Standard way is what? We group it in one. So this you get 4 ones you can get together. And you can get these two also together. Right? When you get them together, your Y, what it becomes equal to? It becomes first 4 is what? A. And the next, the pair is actually equal to your B and C bar. A or B and C bar. Now, we have to try the other way as well. Also, we can try. Let us pair the zeros. Let us pair the zeros. So if you want to pair the zeros, how you get? You can pair like this. Pair like this. And you can pair like this, right? So that, okay. So in that case, your Y, okay. This A bar and A is for your min term. And when you go to max term, this will become A and A bar. This for your max term. So when you do max term based approach, A remains the same, becomes A. Okay, let's go with different colors. That will make it easier. This is one color. Okay. This is another color. So in the first case, what happens? This becomes equal to A or, and in these two, that is you're focusing on these two, what is common and what is changing? C is
A
changing.
plus B into
So this will be A plus B, right? And for the blue expression, A is common.
A plus C bar.
No. Yes, A plus C bar, correct. A plus C bar. Okay. So this is how you get from the POS expression. So from the SOP, this is the SOP and this is the POS. You can convert the POS into SOP. You can, if you expand it, you will get the same answer. Okay, there will not be a change. Right? Do you want me to expand it for you to understand, or is it fine? Okay. Purvika is not understanding POS. Okay. Check. Let me. Okay. What about others? Is there anyone else having any doubts here? Any queries? Any doubts? POS is slightly tricky, so I'll revisit it one more time. Okay. So, okay. This is the normal SOP. SOP, what it does, it takes, what I want you to remember is, this is your A, this is your BC, and your numbering remains the same. Numbering remains the same means this is 0, this will be 1. This is 0, 0, this is 0, 1, this is 1, 1, this is 1, 0. Okay. So this is going to be your, so in first we are thinking in SOP terms. So this will be your A bar, this will be your A. This will be what your, this will be your B bar and C bar. This will be your B bar and C. This will be your B and C. This will be your B and C bar. Okay, this is in terms of SOP. Your numbering is what? 0, 1, 2, 3, 4, 5, 6, 7. That does not change. Okay, that does not change. Now, let's go for POS. POS is what? Your numbering does not change. Numbering means what? Okay, first this is A, B, and C is here. Number, this is 0, this is 1. That does not change. Okay. This is 0, 0, this is 0, 1, this is 1, 1, this is 1, 0. That also does not change. But what changes in POS? Your 0 represents A, not A bar. Your 1 represents A bar in this case. Now, your 0, 0 represents what? It represents B or C. Your 0, 1 represents what? It represents B or C bar. Your 1, 1 represents what? B bar or C bar. Your 1, 0 represents what? It represents B bar or C. Okay? Is this clear? Your numbers remain the same. That is, this is still 0, this is still 1, this is still 2, this is still 3, this is still 4, this is still 5, this is still 6, this is still 7. That numbering remains the same. But 0 changes, the meaning of a 0 is different in SOP and POS. Okay? All right. So till this part is clear. Let us go now over here. Where are the ones? The ones are 4, 5, 6, 7, and 2. So what are your ones? This is your 4, 5, 6, 7, and 2. Okay? You focus on the ones. In SOP, what? You focus on the ones. So then what do you have? You have this right over here like this, and you have it over here like this. So then you can simplify and you can get which is this expression. But in the POS, you focus on the zeros. You focus on the zeros, so you focus on this, this, this. Right? You focus on this. And this, you can group it. And this, what do? You group this over here like this. And then you group this over here. Right? From that, you get your POS expression. So let me rewrite the POS expression for our understanding. In the POS expression, how do we write it as? Y is what? A remains the same, right? And in the first two rows, what it is? B remains the same. So it is Y equal to A or B. And again, in the second combination, A remains the same. And what remains the same? C bar remains the same. Okay, so this is the POS expression. Okay. I hope this has cleared your, this has got you more understanding regarding this concept. It's a simple concept, but it's best to, know it well. And I'll also, this meeting is being recorded. So you will be getting the YouTube link soon where this will be uploaded on YouTube. The notes also which I'm writing also will be uploaded on YouTube, not YouTube, but on the drive. So I'll share the link. So I have shared in the meeting chat the YouTube link and the drive link. So the YouTube link is the link for the channel and the drive link is the link where these notes will be uploaded. Okay, the notes which I'm writing will be converted to PDF and will be uploaded. All right. So you can access it over there as well. Okay. So let us have a break. We'll have a break of 2 minutes. Okay, the meeting will still proceed. We'll just have a break of 2 minutes and then I'll come back. Huh? Okay. So we'll start with the next part, that is logic gates. So what are the common logic gates that you have used or you're familiar with?
And, or, not, nor,
Okay, very good. NAND, okay.
XOR, XNOR.
Yes, XOR, XNOR. Okay. So now, can you tell me what does this expression? Suppose I have this expression A or B and C bar. How will I How will I draw the circuit diagram of this? How will you draw the circuit diagram of this?
Using OR gate and AND gate.
Okay,
Not
suppose
gate also.
yeah, NOT gate also you need. So
First
you
and should be written, sir. Then after not get.
there's different ways, Suppose you have B is here, C is here, you have a NOT, you get C bar, then you write an AND gate. Okay. Oh, I am so sorry. I have just done the opposite. So sorry. So sorry. So this is your this is your AND gate. Yeah, correct. And then your OR gate. Okay, so this is your Y. Huh? So you have B and then you AND it with C bar. So this will be what? Your B and C bar, and this will be your A, and this is your Y. Okay. So this is how like you make your Boolean expression, you make it into a circuit diagram. Okay, so let me ask a question. Suppose this is your A, this is your B, this is your C, this is your Y. You can draw the truth table. Can you draw the truth table of this? Say this is 0, 0, 0, this is 0, 0, 1. This is 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. And the truth table is what? The expression is what? Y is equal to A or B and C bar. What will be the output over here? Can anyone tell me? The truth table, how will the truth table look? First will be 0. Achha. Okay, 0 next.
0.
Okay. 0. Okay, next.
0. 0.
This will also be 0.
1.
1,
This is 1. Okay. Next one is
0,
0.
oh, then next one is
1.
next one.
1.
Okay. So for the all it is 1.
1. 1.
Yes. Okay. So this is the truth table. Suppose. So this is the truth table. Very good. You have found out. So those people who have not been able to follow why it is this, you can go and you can try it later. But y equal to a plus b and c bar, this is your truth table of this. Okay, this is the truth table of this. Now, assume you have a, b, c, and y. Okay, a changes like this, right? Oh no, let me draw it the way standard. Suppose a is all off, then all on, all off. B is off for half the time, on next half, off, then again on. Okay. C is what? It is off, on, off, on, off, on, off, on, like this. Okay. Suppose this is the waveform. This is how it looks with time. So now, let us just write, what does it mean? ABC all 0, 0 means what? Here you see A is 0, B is 0, C is 0. So your Y should be what? Y should be 1 or 0? It should be 0, right? It should be 0. That means it will be 0. Next, what it is? It is 0, 0, 1. Right? So 0, 0, 1 also 0. So you have 0 over here, 0. So that means it's still 0. Then you have 0, 1, 0. Right? 0, 1, 0 means output will be 1 or 0. Hmm? Yeah.
1.
1.
So that means it should go high. Then what you have? You have A is 0, B is 1, C is 1. What is it according to the truth table? A is 0, B is 1, C is 1. According to truth table, what it should be?
0.
Yes.
0.
0, right? So it will be 0. Next, A is 1, B is 0, C is 0. What should it be then in that case?
1.
Yeah, 1, right? And in the next further cases, as long as A is 1, it is I. Okay? Then again it all becomes 0. Then again it becomes 0. Okay? Yeah. So this is how it looks with time. Okay, when you look at the diagram, when you look at the waveform, how it varies with time, then you'll see the output also is changing with time. So any questions in this? No questions? Okay. So you know various logic gates and other things. So you can write an expression, you can simplify it, like that would be simple for you. What I would like to introduce to you guys is something which is really very interesting for me. I hope it will be interesting for you as well. I like to do certain simulations. Okay. So I'm not told it. Just hold on. I'm opening a simulation. So this is the software, Simetrix / Simplest Elements. Okay. We have Simetrix / Simplest Elements is the free version of it. Okay, it's the free version. There's the advanced versions are there, which you need to have a license, everything. So since many of us will not have the license, I'm working with the free version. Okay. Yeah. Oh my. Okay. Okay. I'll also share the link of this so that you can download it for your own understanding. Later you can download. I'll just share the link of it. 1 minute. Okay, later I'll put the link in the YouTube video so you can check it out there. Okay, how to download this. So let me go slowly. Let me go to my circuit. This is over here. Here. These things let me remove it for the time being. So this is a clock source. A clock source. I'll just show how it looks like. This is my clock. It's a digital signal. Okay. This clock is going to a counter, 2-bit counter, and that is generating the bits B and A. Okay, B and A. Let us understand this. Simple. So I'm going to run it. I'm going to run it. And I want you to notice something. Problem with this. Okay. So clock is going from 1 0 1 0 1 0 1 0. Okay, this is your clock. When your first clock comes, your B is 0, A also is 0. When your next clock comes, your B becomes 1, A still remains 0. When your second clock comes, your A becomes 1 and B becomes 0. And when your third clock comes, B is 1 and A is also 1. And when your fourth clock comes, your A is 0, B is 0. So this is of a counter. Okay, this is of a counter, right? This is like a counter. You will learn about counter more and more. I am just introducing it so that, to encourage you, to, motivate you to understand real life examples. And, you should have that hunger for more. You should have that expectation for what more I will study in digital circuits. So based on that motivation, I have shown this. So your A is what? 0 0. Here it is what? 0 1. Here it is what? 1 0. Here it is 1 1. Okay. So this counter is used to generate that gate signals A, B, all that A, B. It is used to do it. Okay. Now let me check an AND gate. We have an AND gate. I will enable it. Okay. Now let me run it. Let me now set the clock to be 1. This is 1. A should be 4. A should be second, so 2. 6, 3. Okay, and this I think is 4. Let us close this. Simulate it once more. Okay. So I have a clock A, B, and the AND gate. Okay, you see the AND gate. Is it clear to you guys, or is it small? Like I should zoom out, I should take it out somewhere or something? Is it clear or is it this? You let me know. Okay, if you're finding any challenge in looking at something, you let me know. So A is 0, B is 0, so your AND gate output should be 0. A is 0, B is 1, AND gate output should still be 0. A is 1, B is 0, so your AND gate output will still be 0. But when both A and B are 1, then your AND gate output is 1. Okay. When A is 0, B is 0, again it becomes 0. Is this clear how your AND gate, you can check whether your AND gate is working? Is this clear or not? Any doubts here? Okay, you guys are a bit silent, but yeah. So I'm just showing further. Okay.
We
So now,
understand, sir.
okay, very good. So now let us see the OR gate. Okay, OR gate. Let us check the OR gate. String order is fine. So I'll close this. I'll resimulate it. Now you see the OR gate. When A and B are both 0, OR gate output is 0. When A is 0, B is 1, OR gate output is 1. When A is 1, B is 0, your OR gate output is still 1. And when A is 1 and B is 1, again it is still 1. But when both A is 0 and B is 0, then your OR gate output is 0. Okay. Right? So what is actually happening? What is actually happening is we have checked in this simulating software that AND gate OR gate is working. Okay, your AND gate OR gate is working. Right? This is the case. So now let us start doing a little more challenging thing. Okay, you guys will slowly understand it and all. Let us try this circuit. Okay, let us try this circuit. Let's just make an attempt to make this circuit. I'm just giving you a walkthrough of it so that you can slowly, once you download this, those who have interest, those who want to learn more, you can check it. Okay. So let me make a new simulation. Let me make a new schematic. Okay, I make it a Simetrix schematic. I go to place. I go to digital. I go to digital pulse. Okay, a digital pulse I'm going to. This is my clock. Okay, this is the clock. A clock is a very important thing in digital part. That, let me say the period is 1 micro, width is 500 nano. This is the by default one. I will leave it as it is. Okay. Now I wanted, you know what, in the question, in the this example which we did, what you have A, B, and C. You have 3 bits. You have 3 bits, right? You have 3 bits. So that means I need a 3-bit counter. I use a 3-bit counter. So what I do, I go to place, I go to digital generic. In digital generic, I go to counter. Okay, I've gone to counter. Number of bits which are there in the counter, I want 3 bits. Okay, I'm not adding reset and other things. This is more advanced. We'll do it later. Okay, 3 bits. Okay, so to the counter, I get this clock, and then it will generate to me 3 bits. 3 bits will generate. Okay, so it is going to generate 3 bits. Let us see. I'll place what is known as a probe. This is called a probe. And this probe, I will give it the name clock. Okay, I'll give it the name clock. It is a digital grid. I'll use a graph name for it. Check. Oh, graph is not needed actually here. Okay. String is the first. This is the first thing I want to see. 1. Clock. Why is it not saving? It's not saved, right? Save schematic as. There is some issue. It is not able to save the schematic. Show why. Some issue is there. Okay, there is. Scrap this. Let us make a modification in this one only. Or let me try whether I can resave this file. Save schematic as. There's some issue. What is the issue? Save. Let me modify over here. I make it 3 bits. So I get your, what I get here. Sorry. So my A will come here. Comes over here. This will be your B. This is a connector for B. B. C. So those of you who are not interested in, you can leave the meeting. This is kind of like an optional thing. Okay. Then this is C. Okay. This is them. Let me just check whether it's working. Okay. Fine. Just hold on. Just hold on. Okay. These I don't need currently. Disable selected. A, B, and C. All I'll make it digital. Digital. You close it. Let me run it. Okay. So now, if you notice, you have got this ABC pattern, which I had drawn. Okay. If you have 0, 0, 0, then you have 0, 0, 1, then you have 0, 1, 0. Achha, I have to simulate it for more time. Not allowing. Not allowing. What can I do? Okay. 0.5 micro. 50 nano. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Again back to 0, 0, 0. Okay, again back to 0, 0, 0. So now we have to implement what is our thing. We have A or B and C bar, right? So let us go. How do I move it? Acha. Let's move here. We have to place digital inverter we need, and then we need a AND gate, right? So what was it? A plus B or C bar. So you get C over here, then connect it here. So here I am connecting C bar to the AND gate. Then I'll connect B also to my AND gate. Then I will use an OR gate. Place digital OR gate here. And for this, what I will connect to it? A I'll connect. Okay. A. And then this will be my output Y. Y. This also is digital. Digital ABC. So this is 5. Let's run it. Now, if you will see the output, okay, if you will see when A is 0, B is 0, C is 0, it is 0, right? When A is 0, B is 0, C is 0, again it is 0. But when A is 0, B is 1, and C is 0, then it becomes 1. Right? Like how we got it previously. Like if you will remember this, what we got 0, 0, then we got 1, then we got 0, then we got 4 ones, then we got 0. Okay? Let's see whether we got it over here. We got 0, 0, then 1, 1, then again a 0, then 4 ones, 1, 1, 1, 1, then again 0. Okay? So this is how like you can make a circuit diagram, you can check it, you can verify it, you can see the waveforms on the screen and all, and like you will understand your circuit better. Okay. Yeah. So yeah, so is there any questions in this? Any doubts, anything you didn't understand, any mistake which you thought I would have made? You can let me know. Or whether it was useful for you to understand it also, you can let me know, because positive feedback and negative feedback both are useful, right? Yeah. Okay. So this is a way that the element software, I just introduced it, and I hope to use it further in the further upcoming sessions to just show you certain simulations. That is just not, me writing, deriving everything. I want to introduce you to simulations, to software, so that when right now you're just studying the subject, but probably some of you are uh, going to be doing projects and you need something to simulate your ideas, then this is a good platform for you to check all these things. So your ideas and all that, right? Okay. So if there are no queries, then we'll proceed further. Proceed. So sir also mentioned something known as universal gates. What are universal gates?
And NOR.
Yeah. NAND gate and NOR gate. Yeah. So why are they called universal gates?
We can implement basic gates by using these.
Yes. You can implement basic gates using these. So that means you can make any kind of circuit. That is of these combinational circuits. That is, you just have NAND gate. You can implement AND gate. You can implement OR gate. You can implement NOT gate, XOR gate, XNOR gate. All those gates you can implement using just a NAND gate. Similarly, NOR gate also you can modify it and change it and implement it as a universal gate. Okay. So from in then any other thing which sir mentioned also was you can use XOR plus OR. This combination also you can use. You can also use XOR plus AND. Okay. This combination also you can use it. Right. So if you have, let us just take XOR function. Okay, let us not just do universal gates, everything. Let us look at an XOR function. XOR function. What is your XOR function? You have A, B, Y, right? You have 0, 0, 0, 1, 1, 0, 1, 1. Okay. Now, XOR of that is what? Let us say this is the XOR of AB. What is the XOR of AB? It is 0, 1, 1, 0. Right? What is the XNOR of AB? What is the XNOR of that?
1001.
0.
0, 0, 1. Okay. Let us try. This is what XOR. This is A XOR B. And this is your A. What is the symbol for XNOR? Does anyone know? Because I don't recall it.
Dot A dot off.
Okay. A dot. Thank you. A dot B. Okay. So now, what is A bar? And what is B bar? A bar is what? 1, 1, 0, 0. What is B bar? It is 1, 0, 1, 0. Okay. Now I want you to tell me what is the XOR of A bar XOR B bar. What is A bar XOR B bar? What is A bar XOR B bar? 1 and
0, 1, 1.
0, 1,
0, 1, 1, 0.
0, 1, 1, 1, 0. Okay. Good. What is A bar XNOR of A bar and B bar? What is the XNOR of A bar and B bar? What is the XNOR of A bar and B bar? It means the XNOR of A bar, B bar?
1, 0, 0.
1, 0, 0, 1. Right? So it is kind of like clear, right? You know, the XOR of A XOR B. So what we can say, A XOR B is same as A bar XOR B bar. Okay. And A XNOR B is same as A bar XNOR B bar. Yeah, this is a live session. Balaji, this is a live session. Yes. But this session is being recorded and it will be uploaded on YouTube. Yeah. Okay. So any confusions regarding this? A XOR B and A bar XOR B bar also same. And A XNOR B is same as A bar XNOR B bar. Okay. All right. So we have done various things in today's class. We have started with K-maps. Okay, we started K-maps. We started with the 2 variable K-map. Very simple one. We checked it. We simplified the expression. We checked what is the value. Then we went to 3 variable K-map. how do we draw a 3-variable K-map? Then how do we do the grouping when we have written the min terms? Then another question, and then a question where you have to do folding based grouping you can do. Then we went for a 4-variable K-map. How do we draw the 4-variable K-map? Then we considered a question. Then we also included the concept of don't care, how it makes it more better, easier, and all. Then we focused on SOP and POS. We checked SOP, POS, what it is, the significance of it, and everything. Like how we can represent a circuit in SOP or POS. Then we did an example of 2-variable SOP and POS. It is the summation of min terms, product of max terms, how both of them are the same. Then we checked it in a 3-variable K-map. We checked it, SOP and POS. That also then further POS, how exactly POS differs from SOP. What is the slight, thing you have to keep in mind? That also we checked. Then we checked logic gates, how it varies with time, the waveforms we did. We did a simulation also. We showed this counter, and then how do you implement the logic gates in the software, and the waveform, how it looks like, how that matches with the theory which we did, right? And then we studied XOR and XNOR. Okay. So I thank you guys for attending. If you have any queries, you can ask me. If you don't have any queries, we can end the session. Okay. What is an implicant? Okay. Yeah. Implicant and prime implicant. What I have understood is, let us say this is a one. Okay. Suppose you have 1, 1. Let's use a different color. 1, 1, 1, 1. Okay. So to what I have understood is that implicant is all the options. That is this 0, 1, 2, and 7. Let us go to source notes. It will give better clarity because I should not confuse you guys. Go to source notes. What does source notes say? Because I am also not very clear about this implicant concept. So not downloading it. Okay, there's actually a bit details is like issue in the cloud. So I'm not able to download that. So I'm actually not very sure what exactly is the difference between an implicant, what is a prime implicant, what is an essential prime implicant. I'm not very clear about that. So we can, if you guys need it, then in the next session I can talk about it. Otherwise, you can refer to search things and do. Because I am not very clear about implicant and all that. Yeah. For the simulation, actually, I used this Simetrix software. This let me close it and show. Like this simulation I used, which is actually, let us say, a help file about. This is the software. Actually, it's not clear. So can you see the bottom left? You can see the bottom left of the screen. It is Simetrix /simplest elements. So this is the software. It is a freeware That is, the Elements version is a freeware. Okay. Yeah, you can use it also for counters. Flip-flops are there. If I show you, in place, you go to digital. You have your, this is a NAND gates combinational circuit, digital generic. Counter is there. Flip-flops are not showing here, but I think it is there. It should be there. Like, see, you can get a 8-bit counter, you can get. Flip-flops, actually, I used to access it from some examples, so that also can be done. Flip-flops also can be done. Yeah. Okay. So, actually, someone asked, so Indu, this concept of implicant, I'm not very clear, so I'm sorry, I cannot let you know. I don't know. So you can check to sir's lectures and you can go through it. And if you have any doubts regarding that, in the next session, I can clear it, or else maybe you can check in some other references. Okay. Yeah. Yeah. Actually, I'm actually a PhD student at IIT Kharagpur. So for this, we take these sessions. So actually, I take this problem solving and doubt clearing sessions for every week. Week 1, week 2 is already done. They are already uploaded on YouTube. Week 3 also is today's one, which was there. I'll be uploading it hopefully by tomorrow, and so that you can access it. If you need the access to the links, this is the links are here, right? The links are over here. Okay, which domain is better, VLSI or embedded systems? We cannot tell. Depends on the student, depends on what facilities and access you have, right? VLSI is very much, sophisticated. You need to be very good in analog electronics, digital electronics. It depends if you do analog VLSI, digital VLSI, all that depends on that also. You really need very good teachers to teach you. Embedded also is somewhat similar, but embedded is a little bit more, generic, little bit more easier. VLSI is something which you have to spend lots and lots of time and understanding to do. Yeah, I'm actually not a VLSI guy. I'm also not an embedded guy. I'm actually a PhD student in control systems. Okay, but I work in my lab is called Embedded Power Management Lab, and there I have been given the privilege and access of working on various microcontrollers. So I worked on the TI microcontroller and the STM32 microcontroller I worked on. And though there it has some concepts of embedded. Regarding VLSI, I have not dedicatedly, I have not worked on VLSI, but there are people in my lab, few of them who work on VLSI and all those things. So they have a better idea like that. Yeah. So you can check, you can understand, probably you're trying for masters and all that. So getting VLSI or embedded, it differs. Okay. You just check whether your basics are very good in electronics so that you can try for VLSI. Because it is a complete thing of electronics, VLSI. Any other questions? Okay. So if you have no other questions, we can end the session. So thank you for joining. It was really interesting teaching you guys. So based on limited things which I knew, I taught. So it's not a full perfect, and it's not this complete understanding for you. You will learn better when you go through such course, when you solve it on your own, derive the expressions on your own, right? And all the best. Okay. Yeah, control systems, you have to go through some books and all. I actually was taught control systems by very good teachers and their notes was very good. So I did not have the habit of going through books. So control system, basically you have the transfer function, you have the block diagram reduction, Mason's formula, and further than that, you have your time domain, frequency domain, Bode plots, root locus. After that, what is there? Bode plots, root locus, Nyquist diagram. Those are the things are there in control systems. it'll take time. Okay, control systems is like what you build, you do something, and then you do the next part in something, and then you add certain part to that, and you get a different concept. So in all these, these advanced things like control systems, VLSI, you will learn well if you have a very good teacher. Okay, because I had the privilege of having very good teachers who really, stimulated my interest. So that enabled me to learn it better. Okay. So Balaji, like you're a student or you're a what are you, like a BTech student, MTech student or something? Others also can ask questions. Okay, you're a BTech student. Okay, okay. You're in the second year, third year, which year? Okay, second year. Okay. You see, you're just starting, just starting. Yeah, yeah, yeah. Yeah. So yeah, second year is when you just start electrical kind of electrical or electronics, whichever is your BTech thing. So yeah, you patiently attend class and learn it and try doing it on your own. Like I recommend to try learning on your own, and like you attend class, you listen to the teacher, you take notes, everything, but you have to go and revise on your own. Like no one can, take all that knowledge and put it into your head. No one can, like do how we do file transfer. Like that knowledge transfer doesn't go directly. Knowledge transfer will go once you are willing to learn. That is important. You have to be willing to learn, and you also have to put in your own effort. Then knowledge transfer will go in. Okay. Yeah. And in all the problem with engineering and everything is you should have your foundations clear. What you learn in your second year, you have to use it in your third year. What you learn in, so you cannot miss the second year part. If your second year part is weak, then you will struggle in your third year. Okay. Like in usually, like certain subjects are the foundations in second year, you use them in third year, and then probably you would use them in fourth year, and so on, right? So it is very good now to be consistent and get the fundamentals clear. Okay. Yeah. Okay, so if there's no other questions, yeah, let's leave it. Yeah, very good. Thank you for joining. You can all leave. Thank you for taking part. All the best. Okay. Good night. Bye. Okay. Yeah, thank you. Thank you, everyone. So I'll end the meeting.